For our project, we have chosen the open source software Bitwarden for its use as a password manager, secret manager, and pass key innovator. The software can be used by a business to manage their employees' passwords and help protect the customers and client data stored on the company's servers. We will be utilizing both the client-based Bitwarden, which includes the desktop, web, and browser extension, but not the mobile application, as well as the Bitwarden server infrastructure and backend. The software offers a password manager that can be used by all the employees, as well as the account managers, which allow the automation of the user's accounts from a centralized admin panel. Our hypothetical operations environment. Our hypothetical operation environment consists of a small web development team with a web page, e-commerce, and web and backend server components. This web development team needs access to security solutions that will protect the DMZ that holds their public-facing web page, as well as their back-end development resources and servers. This team might also expand in the future, assuming they do not currently possess off-site personnel and the end-to-end encryption secrets manager offering and would allow them to protect their data in transit. Our key motivations. Why Bitwarden? Bitwarden being chosen by our team as a research project is motivated by several factors, especially in the area of cybersecurity, software development, open source ecosystems, and user experience. Here are some key motivations. On cybersecurity, it addresses risks like breaches and identity theft. Open source, transparent architecture for research and contribution. Cross-platform usability, access from unlimited devices. Comparison potential, analyzes against competitors such as LastPass and Dashlane. Community-driven, study collaborative development and innovation. Business model insight, understand free versus paid tiers. Now let's move to our next section, which are the security features. The top security features for Bitwarden are it's end-to-end encrypted with zero-knowledge architecture. It also have a two-factor authentication option. It has secure password sharing and also password generating. It's also self-hosting, and it's Vault Health Report. It has a Vault Health Report as well as an audit trail. It's also compliant with security best practices guided by the GDPR or HIPAA. Perceived threats that we want to note. Bitwarden is a popular open source password manager, but like any software, it may have perceived and potential threats.
This presentation will discuss the use cases that each team member developed. They are listed in this slide and will advance in this particular order. First use case is secure code. This use case highlights the securement, storage, and management of sensitive information, such as credentials, API keys, or other secrets. Below are security requirements, multi-factor authentication, role-based access control, and audit logging, as well as security features that Bitwarden does offer. Upon looking at this use case, I do not see a gap, and Bitwarden is able to accommodate all of the requirements that need to be met. In the second use case, I have user logon. This use case is assurance of accounts with sensitive information on each employee security that they are the only ones with access. Again, we have security requirements as well as the security features that Bitwarden has available. And with this use case as well, Bitwarden was able to accommodate the requirements such as password hashing and salting, input validation, as well as the previously discussed multi-factor authentication and audit logging. In the third use case, we had customer and supplier. This use case displays the relationship between front-end customer, supplier, bank, and possible outside threats. Once again, security requirements and security features are listed below with the websites to Bitwarden and where they do accommodate. Security requirements, encryption of sensitive data, implementation of delivery, and previously discussed multi-factor authentication and role-based access control. The next use case is secure payments. This use case secures an employee's company's credit or debit cards using Bitwarden, assigning employees with specific access controls and multi-factor authentication. Security requirements and security features are listed below. There were no gaps. Everything was covered by Bitwarden. Under the requirements, intrusion detection system, secure transaction process, multi-factor authentication, audit logging, role-based access control, and encryption of sensitive data. The last use case is responding to a data breach. This use case identifies responding to compromised passwords in a known data breach and how to secure updated passwords in Bitwarden's vault. Below are the security requirements. Data breach report, multi-factor authentication, password hashing and salting, audit logging, role-based access control, and encryption of sensitive data. Further below are the security features, which Bitwarden does accommodate, so therefore I do not see any gaps in this use case. Thank you.
Bitwarden's open source software ensures robust authentication by enforcing proper authorization measures. Employees must meet strict standards to access the operating environment and secure systems, addressing concerns about trustworthy user authentication. This creates a safer, more controlled environment, reducing the risks of breaches from unauthorized access. Next, protecting code with secrets. Bitwarden's Secret Manager is a cornerstone for securing both public-facing systems and internal resources. It employs strong encryption and controlled access to safeguard sensitive information. Features like centralized secret management, regular rotation, and secure logging are instrumental in mitigating risks associated with credential breaches or misuse. When it comes to credit card payment information, Bitwarden must use robust security measures such as role-based access control, otherwise known as RBAC, advanced encryption, and real-time network monitoring. These measures must protect sensitive company financial data against threats. However, risks from human error, sophisticated attacks, and insider threats remain areas for continued vigilance. As we move on the front lines of breach detection, Bitwarden integrates with the Have I Been Owned, otherwise known as the HIBP, spelled with a P, not an O, database to identify compromised credentials. Users are promptly notified and guided to update their passwords, effectively minimizing potential risks while highly effective. The reliance on external databases can delay detection of unknown breaches. Now, we will move on to finally talk about Bitwarden's security of customer and supplier contracts through advanced encryption protocols, zero-knowledge architecture, and TOTP authentication. These measures ensure confidentiality, integrity, and availability while providing compliance with audit trails. Though well rounded, future proofing against quantum, post quantum encryption risks is an area for growth. Now, let's summarize the key alignments and gaps that we as a team identified in our meetings. First, for the minimalized authorized users, we identified that, hey, strong measures like password hashing, salting, and 2FA effectively reduce unauthorized access risks. However, there was a weak default password policy, and careless administrative practices can remain vulnerabilities for this. Now, as we move on to securing credit cards, we see here that encryption and RBAC addresses they address many threats, but the physical risk and the human factor need greater attention. Now we move on to protecting code with secrets. Encryption policies and misconfiguration alerts are effective, though the endpoint security and independent vulnerability assessments need further integration. Then we move on to checking compromised passwords and making sure that data is being monitored. Here we see that effective breach detection through HIBP ensures privacy through manual user updates, which may delay securing accounts. So even though they detect these anomalies and they detect these issues to try and ensure privacy, the updates are delayed. Finally, we move on to encrypting sensitive contracts. The best practices are followed, but the absence of post-quantum encryption readiness and recovery options for lost master passwords could pose as challenges. Finally, we move into the conclusion. In conclusion, this project showcased the strength and adaptability of Bitwarden's security features while highlighting areas for improvement.
This is the data flow diagrams and modeling. Okay, so we first started off with Bitwarden's login diagram, and this diagram shows interactions between components in Bitwarden's client-side security flow. The main focus is on managing user authentication and managing secrets securely. This diagram also highlights key security controls like multi-factor authentication, encrypted passwords, and cryptographic key exchanges. The trust boundaries show areas where more security is needed, like making sure we have secure communication protocols. It shows how Bitwarden manages login requests, validates credentials securely, and leverages multi-factor authentication to enhance its protection. For the next diagram, this is on Bitwarden's data breach diagram. It shows how a Bitwarden client interacts with the external systems to process breach checks, report updates, and communicate breach information to the end user. A breach check results and account activity use sensitive information which require encryption. It also updates from the breach reporter. It must be validated for integrity to avoid false data injection. The risks that come with this is the trust boundaries expose areas where external inputs could be manipulated, and then the breach check process involves third-party databases, which could introduce vulnerabilities. Alright, so now for the gaps. The first gap that we noticed was ensuring that data hasn't been tampered with or interrupted, and it can lead to DOS attacks, and our logs can be tampered with, and this would be untrustworthy without our knowledge. So for the first gap, we must, with the data tampering impact, this leads to system inconsistencies, unauthorized updates, or false breach reports. And then with a denial of service, this impact, it can make our service become unavailable, which this would degrade trust in the system's reliability. And then lastly, log tampering. The impact of this, it can lead to incident detection and post-incident analysis, like being tampered with, which we need for the mitigations. For data integrity, we must use cryptographic hashing and digital signatures to verify the data's integrity. And then for DOS, we should use request validation at entry points and use a monitoring system to flag unusual request patterns. For logs, we must make sure to use hash validation so they can't be tampered with. The next gap is that input sanitization is assumed to be faultless, but it could have flaws. So if there's someone using malicious inputs, the impact of this is it could lead to SQL injections, code injections, or malicious inputs could just cause service crashes. And then for the mitigations for this is we must enforce strong validation rules and use structured data formats. For the boundary protection, we must make sure that we validate inputs as they cross our trust boundaries. And then the last gap is validation service is assumed to be faultless, but it could have flaws. The impact of this is it could we could lose trust for breach detection, and they could bypass the security due to unverified breach updates. For mitigations for this, we must use multi-step validations, which use things like hashing verification and source authentication. Then we also must log all validation failures for future analysis. And then lastly, we must make sure that the database of breaches gives reliable, trusted data so we know what is going on. For our summary, we recognize that Bitwarden's main functions can be summarized with the first of the data flow diagrams, where there's an external entity interacting with the Bitwarden client, and that clients sending data to a data store.
To begin, code review is an essential process in verifying the security of any potential software, whether open source or not, that a company or organization is planning on using. To accomplish this, we must have a detailed plan of attack to find and mitigate these issues before we take on this new software. Our code review strategy began with a scenario-based approach, using the use cases we have developed previously to identify weak areas to focus on. We then presented common weakness enumerations to the group and collectively decided on which CWEs fit best with the use cases and the Bitwarden application. These CWEs were then delegated to the team members to focus on individually through manual review of the code. Automated review using code review tools was done by each team member, and then the results were compared to the CWE that each team member is investigating. There were two automated code review tools that we used. For Aikido Security, it ran an automated code review over the entire Bitwarden repository. As a feature of Aikido, it tries to recognize false positives and cut them out of the final view of issues to simplify the reviewing process. The total amount of issues Aikido was able to find was 89, 139, but about 50 of those were cut out by Aikido as false positives, so there was 89 issues that were not listed as false positives. However, it missed some of those as false positives, and that number should really be closer to around 70. Leaving the false positives should be increased by 70, so it would leave only around 19 or so actual issues. And most of these issues were low-level or medium-level issues, and the one critical issue was just an out-of-date component. The deepscan.io scan found around 184 issues, a majority of which were issues claiming that a null value was used instead of an integer. However, on further review on all cases, these null values were handled correctly, and these were false positives. The second most common issue was the constant condition issue, which is a result of Bitwarden hiding the secrets required to maintain secure code. The rest of these issues are uncommon, with only a few instances of each, and most low priority. These are the 8 CWEs the team selected during a group meeting while utilizing a scenario-based approach. The CWEs map to each of our use cases that were discussed earlier. These can be mapped to our specific use cases, such CWE 200 and 522 can be mapped to the secure code use case. CWE 267 and 269 can be mapped to the secure payments use case. CWE 290 and 603 can be mapped to user logon, and CWE 326 and 327 can both be mapped to the data breach and customer supplier use cases. After examining the source code on GitHub repository, we found that Bitwarden typically has excellent security controls in place. However, we found that in CWE 327, there were instances where Bitwarden uses hard-coded authentication credentials. The impact is unknown to us, but we assume to be not a problem. As for the rest of the CWEs, we believe that we have strong justification for security of the software. So our features of focus were authentication, encryption, privilege escalation, and spoofing. For authentication, we found that the authentication controls are strong, aside from the Bitwarden send authentication that we found in key.service.ts. And aside from that, we found no significant indication of improper authentication. For encryption, we found that encryption uses strong cryptographic controls with many rounds of password hashing to reduce the threats of brute force attacks. For privilege escalation, we found that the controls in authentication, along with Bitwarden differentiating between admin and non-admin authentication requests, provide strong reason to trust a privileged user. For spoofing, we found that the encryption and authentication procedures require master key combos, which reduce the likelihood of spoofing. Given the advanced development of Bitwarden and the amount of significant improvement we could offer in terms of coding support or design changes is quite limited. However, throughout this project, we have accrued a significant amount of documentation and support surrounding the use of Bitwarden with various use cases as well as assurance cases. Documentation provided by this project could help other project managers when deciding which open source software to use by reviewing the use cases and assurance cases from this project and matching it to their own potential use cases and assurance cases.